The BiaQIm Image Processing Suite, or BIPS, is free, open-source, cross-platform software for image processing, written in the C programming language. One of the strong points of this software is its extensive deconvolution options. The software comes with a simple step-by-step example guide to show you how to use non-blind deconvolution with the BiaQIm GUI. And there are also several demos for using some of its more advanced features, like blind deconvolution. In this video, I'll demonstrate how to install the BIPS and take you through the step-by-step guide as well as the blind deconvolution demo on both Microsoft Windows 10 as well as on Linux. I don't have any Apple hardware to test these things on macOS, but macOS users should get some clues from the Linux demos, and if you get these demos working on macOS, perhaps you can leave your insights in the comments section to help other macOS users. So here we are on Microsoft Windows, and the first thing to do is to go to the download site, which is www.bialith.com. So put that here. And then to get the software, on the menu on this left-hand side, you click the button called Software. And you see there are a number of downloads. I provide the user manuals as a separate download here because they do not come with the binaries for Linux or macOS or the source code. However, all the user manuals do come in the installer download for Windows, so we don't need to download the manuals separately. So let's just click on the installer. That'll take us to the Proton site where the downloads are kept. You click download and you'll notice the progress down here, and it should download to your downloads folder, which I have opened up here. Okay, so the download is complete, and now we have the setup.exe in our folder. Let's just minimize these windows. To install the software, you simply double-click on the setup.exe. Do not install it as an administrator because this does not need admin permissions. It only installs for the local user. So simply double-click like this. Now, you may find that Windows Defender tries to stop you running it by warning you about it being unrecognized software. You get around it by clicking this More Info link and then selecting the option to Run Anyway. So now it's running the installer. If you agree with the license, click I agree. I advise you keep the defaults, so just click Next and then Install. Because the BIPS is free software, it's easy for anyone to host a copy of it on their own website, and this often happens with certain freeware and shareware sites. However, these sites can also package malware with the downloads, so to keep yourself as safe as possible, I strongly recommend you avoid downloading the BIPS from any site other than the single official download site I told you about earlier. So, setup is complete. You can click Finish. We have the icon for the GUI program BiaQIm here. And what we're going to do now is go through the step-by-step deconvolution demo. So to do that, go to your Start menu, find the BiaQIm Image Processing Suite group, which is here, and then open the Deconvolution Guide PDF. So I'll click on that, and that will give you the step-by-step instructions you need to do the deconvolution demo. The first step is showing you how to get the folder from the main menu group, because the folder contains your test images. So let's do that. So go to your Start menu, go to the BiaQIm Image Processing Suite group, open the DC test folder by just clicking this. That will bring up the folder that has the images that we're going to use. So that was our first step. The next step in the guide is to load the sample images into BiaQIm. So I'll show you how to do this. So we'll start our program, double click on the icon here. This is the BiaQIm GUI. Starts off with a console window, which will give us feedback, but you need to, if you're willing, to accept the license agreement before you can start the program. So you can just type yes in there if you accept it, and then process my response, and then that will give you the program. So now do the next step, which is to drag the moon fits image into BiaQIm. So this is the moon fits image. We'll just drag this into this blue square here. That shows the image. If we want to, we can make it a bit larger because it's a small image for this demo. So just click on this magnifying glass, make it 4 times bigger. So there's our blurred moon image. And the next step on the step-by-step guide is to choose deconvolution from our process tab. So we go to the process tab on BiaQIm like this. We go to choose and you select restoration, iterative, non-blind. Click on that. We'll give you the settings tab for the iterative, non-blind deconvolution. The next step, as we see on the guide here, is to select the settings for the type of deconvolution we want. So first of all, we select the algorithm. We're going to use a Landweber LSQ. We're going to keep this as Fourier. And we're going to use a Biggs Ave 2 accelerant to make the algorithm work faster. We want verbose output, so we click this verbose box. And the only thing we're going to change in these convergence criteria is just the maximum number of iterations, which we're going to put as 128. So that's what this thing is explaining for you to do. Then we're going to go over and consider pre-processing. So go to the pre-process tab. We're going to use the solve boundary method to prevent ringing from the boundaries of the image. And then we're going to go over to the point spread function, the PSF tab here. Load the PSF. We can do that by simply dragging the PSF fit from the folder here to this rectangular area. That will load the PSF and automatically set the height and width. It's got this normalized box clicked, which is good. That's what we want. That's the default behavior. So now we go to the other tab, and on the other tab we're going to set apply constraints. So tick this box. We're going to leave the lower bound at 0 and we'll make the higher bound something a lot higher than it could ever be. So we'll put the number 1024. Because this image will never have a pixel that goes that high, so we're going to avoid saturation at the top by putting in a higher number. Then on the admin tab, we go to the admin tab and we change this to log file based on output. So this will give us a log file for the deconvolution, which is based on the output image name. So that's all done. Now we can say OK, click this button, and it will give you the input-output configurator. The input is image 1, which is this image here. This is image 1, 2, 3, and 4. Okay, so the input is image 1. We need to change that to what type of image it is, which is a fits file. So select fits. The output image, we don't want to overwrite image 1, so we'll select image 2 as the output, which is this here. We'll give it a name. Let's call it LWDC moon.fit. And we will again have to give it the type of image that we want it to output. So we'll say fits again, and we'll click on this box here that says load result. So that's clicked. And now we're all set up to run the program. As soon as I click on this start button, which is the next step along the way. So that's all the step-by-step guide that I've just showed you. And then we click the start button and you'll see the output from the deconvolution, intermediate output in here, and the image will automatically be loaded once the iteration's complete. So just click on the start button once. The deconvolution is running. You can see the current iteration here and the residual, and it's done it and it's loaded the image there. So that is the example of deconvolution. If we can look at the before and after, if we go back to the input-output tab, click on the file list button, and you can go between the before and after by simply dragging your mouse between these two options, before and after. Remember, it's a small image, that's why it's pixelated. We've zoomed in on it quite a bit. So now we'll zoom back out. So that is the step-by-step example. And you can see in our work folder, our DC test folder, the new image, which is this LWDC moon.fit. That's the name I gave it over here. And we also have a TSV file, which is the log file, and you can read that, and the manuals will explain what the various data in that file is. Now, if you want to explore all the various other options for deconvolution via the graphical interface of BiaQIm, You can do that by reading the user manuals here. And there are 4 manuals. The BiaQIm manual is called QI manual, and that will give you the various options you can use via this graphical interface, the BiaQIm interface, this manual. But this interface, although it has many options, there are many more options that you can use that are not available via this graphical interface. So to find out even more about the options of deconvolution, what you really want to look at is the BIaRAM manual, BA manual. So I'll double click that, because this is the manual for all the command line programs. And you'll find there an alphabetical list of the programs, and the deconvolution ones begin with decon, as you can see there. So there are lots of different deconvolution programs. Deconvolve is here, which is the one that we've been using. And there are many options that I haven't described in this demo, and that you can't access through the graphical interface, only by using it by the command line. So this is where you go for the detailed explanation of the various options and what you can do with this program. Okay, so that was the quick step guide explained visually in Windows. Now, the next thing I'm going to do is take you back to the internet, and we're going to have a look at another demo for deconvolution, this time the demo for two-dimensional blind deconvolution. And for that, we're going to go to this website, www.deconvolve.net. So, bring up a new tab, deconvolve.net. And for this, you will go to the software section here. So you can just click on software. This gives you a link back to the BiaLith site to download the BIPS, which we've already done, so we're not going to do that again. This second part here takes you through the step-by-step deconvolution example, which I've just shown you, so we're not going to do that. Now, what we're going to do is download this blind deconvolution demo, and I'll show you how to run it. So we'll click on the demoblind.zip to download it. That should download it to your downloads folder. We can close this DC test folder now because we don't need it. And we can close the browser. Now, we're not going to use BiaQIm GUI for this demo, so I'll quit it. Okay. And the demo is here, demoblind.zip. So unzip it. You'll need some kind of unzipping software on your computer. I like 7-zip. Extract to demo blind. So I've right-clicked on the zip file. I've selected extract to demo blind, like this. Then we go into the folder that we just extracted. Then we go into the files that were in the zip, demo blind files, and we'll see all this. These are the files. Now the README will explain how to do this, but it's very simple. If you're on Microsoft Windows, all you need to do is run this demo BMI bat file. Now, Windows may not like you running it. Let's see what happens. But simply double-click this bat file, and that should run the demo. And so it's running the demo now. You can see the intermediate outputs, statistics for the blind deconvolution. And you can also see the image and the PSF, and you can watch how they evolve as the deconvolution progresses. And this graph shows you a graph of the residuals from the deconvolution at various intervals. So we're starting off right at the top. Remember, we can see how it gets lower and lower, the residuals, as the deconvolution progresses. You can make these images bigger. So view zoom times 4, for example, that's the current estimate of the point spread function. And you can say view times 4, that's the current estimate of the image. You can see we're on iteration 35. We're coming down on the residuals very nicely as the estimates of the solution and the PSF get better and better. If you want to run this program on another operating system like Linux or macOS, you won't be able to do it by just double-clicking on the bat file. So I'll talk more about that in the sections on Linux. This demo also demonstrates the use of this program, CLV, Command Line Viewer, which is part of the BiaQIm Image Processing Suite. You won't be able to run this demo unless you first installed the BiaQIm Image Processing Suite. So now it's finished, you can see your residuals. This is the final result from this run of the image, and this is the final result of the PSF. But what did the initial PSF look like, or the initial image? Let's open up BiaQIm again. We'll type yes. And to see the starting image and the starting PSF, we can just load them into BiaQIm, and you'll find them in this folder that we've just been using. So this is the PSF prior. We'll just drag it here, and you can see it's just a plain square. Just make this a bit bigger because these images are quite small. So this is the PSF prior, and image prior is this one here, image conv fit. That's the image prior. So this was the image prior. So we started off with this as our image. And this is our estimate of the PSF. And you can see that the end result, however, let's make this times 4, so it's the same size as our others. So this was the starting point for our image, and that's the end point after deconvolution. And this was the starting point estimate for our PSF, and that's the end point for deconvolution. And you saw here a file called truth. That shows you what the ground truth is, the unknown true PSF and image. So this is the true PSF, which, as you can see, is very similar to what we got through blind deconvolution. And this is the true image, which again, as you can see, is very similar to what we got with our blind deconvolution. Remember, all we had to begin with was this for the PSF and that. So that's the demo blind deconvolution on Microsoft Windows. So here we are on Linux, and you'll notice I've downloaded the blind deconvolution demo as well as the Windows setup.exe version of the BIPS, and in addition to that I've got the native Linux version that's already been untarred and decompressed into its folder. The reason I've got the Windows version here is because you'll need the Windows version if you want to use the graphical interface called BiaQIm to do the step-by-step deconvolution. Otherwise, you don't need the Windows version if you're using Linux. So, in order to use this Windows version, we'll have to install it using Wine. So make sure you have Wine already installed on your Linux system, and then right-click on the installer and select Wine Windows Program Loader. Then we can just install it like we did on Windows. And actually, it seems to be faster running on Linux than it was on Windows for some reason. I don't know why, but there we are. So that's the installation of the Windows version on Linux, and you can see the icon here. Now, a couple of things to note about running this demo on Linux under Wine compared to natively on Windows. The first thing is it's better not to start the programs from the Wine Start menu. So here they are, but if you start BiaQIm from this Start menu, what happens is you don't get the command window that will give us the useful feedback that we want to see. So instead of doing that, let's navigate to the folder where all these executables are. So go home, it's Wine drive here, .wine, and then drive C, users, your name, so that's me here, then app data, local, and then Tagrosoft. That's where it installs the BIPS. So in here we'll find all the files and folders, including where the images are for our demo. And the TS bin is where all the binaries are. So if we go into here, we'll find BiaQIm in here. Under B, where is it? Here it is. And you right click again, Wine Windows Program Loader. That's how we start it. And then we'll see our command window. So just the same procedure then as it was on Windows. Wine works very well here with this program. So let's go up one, and we'll go to our folder where the images are for our demo. Now, another thing to note is that you'll notice I've navigated on our native Linux file manager to this folder. You could bring up the folder again via the Wine Start menu, but you shouldn't, and this is why. So here it is. Here's the folder. If we click on it via the Start menu on Wine, it opens in a kind of Windows type Explorer. And the reason this is a bad thing on Linux is that the drag and drop won't work. So if we try to load our moon image by drag drop, it simply won't work from this Windows Explorer program. But if we navigate to the folder in our native Explorer for Linux, then it will work. So we can drag the moon, fit onto the receptive area here. We'll get our moon image, make it a bit bigger. And there is some problems with the windows here under Wine. You can just use this button here, toggle it on and off to reset it if you get those funny lines. And then the rest of the demo is just as it was on Windows. So we go to Process, Choose, Restoration, Iterative Non-Blind, select Landweber least squares. Landweber least squares, and we do the Biggs Avid 2. We'll do verbose. We'll have 128 iterations, and then we'll go to Preprocess, Solve Boundary, and then we'll go to the point spread function, drag and drop the point spread function onto here, and then we'll do the Apply Constraints. 0, 1, 0, 2, 4 is our higher constraint. Then on Admin, we'll do based on the output, our log file. Say OK, image 1 to image 2, and they're both fits files. Fits, and then we need to say load result. And we need to give it a name. DCLW moon dot fit, like that, and then we can run it. And again, it seems to be a lot faster on Linux under Wine than it is on native Windows for some reason. So here it is, and we can do our comparison. Go back to input, output, file list. Then we do before, after, before, after. So that was the quick step-by-step deconvolution demo under Linux using Wine and the Windows executables. Now we will do the blind deconvolution demo, but let's go back to our home folder and we'll go to downloads where everything was. And we need to raise a command prompt. But this time, when we do the blind demo, we're going to use the native binaries for Linux. We're not going to use the Windows binaries we just installed. So first of all, let's unzip our, we have to go to the right directory first. So let's cd to downloads, Control-Shift-V, and then we'll unzip the package we downloaded, like so. And our deconvolution blind files are in there. But before we do that, we need to make sure that our BIPS binaries are on our path. So when we call the programs, we'll be able to access them. So if we just try now, say deconvolve, which is the name of one of the binaries. There's no exe involved because these are Linux binaries, they're not Windows binaries. You see it says command not found. So you install them by putting them on your path. And this is a manual installation. So we go into the BIPS Linux binaries. There we are. And the binaries are here in tsbin. So we want to put this tsbin on our path. So we'll do that by selecting it here, copy, and we'll simply say export path equals, and then the path we want, and then we're going to obviously want to add it to our path. We don't want to replace our path, so we do that colon, and we'll do $path like that. So if we click that, we've now added the binaries to our path. And another thing we need to do, sometimes you might have to make them executable, give them executable permissions. So if we cd to that directory, we can do that by saying chmod +x, and then local files, all of them, and then that's that. So now, if we go back to, let's go into where the demo is, So we'll copy that. CD, Control-Shift-V. There we are. So this is where our demo is now. If we type the command deconvolve, we should see the help message. There it is. So now we've got our commands. We're not quite ready to run the demo because the demo is in this BAT file, which is designed for Windows. So let's open this in a text editor and make some changes. So Genie is what I use. And first thing I'm going to change is all capitalizations must disappear and anything with a .exe must disappear. Otherwise, the command is the same. So let's do that. Small d for decon, small BMI, and get rid of the exe. Now, Linux is a case-sensitive operating system. You can see here the settings file is called DCBMI capital S set, whereas here it's actually DCBMI little s set. So we need to change that to little s. Now that's our command line ready to use, but we first need to make some edits to this settings file for it to work on Linux. So take this into our text editor, and we need to change the name of the program we're calling from deconvolve with a capital D to deconvolve with a little d, and get rid of the .exe. And then we go down, there's another program we're going to be using, which is the CL viewer to show the intermediate results. Get rid of the .exe on the CL viewer, because we're using the native Linux binary version of CL viewer. And one last thing, get rid of this Windows / and make it into a Linux /. Now everything should work. If we save that, we don't need to save the BAT file because we're not going to actually run it as a BAT. We're just going to copy this as our command line. So copy. Let's get this window out of the way. And then we'll do Control-Shift-Paste to give us our command line. And then hit return. And now you can see the demo running with native Linux binaries in Linux. This is the X11 version of command line viewer, which is a similar program to what I wrote for Windows as an exe file. And it's working a lot quicker than it did on Windows. This is the native Linux. It's finished already. 64 iterations. There's our final result of the image and of the PSF. So that's an example of how you run the blind deconvolution demo in Linux using the native Linux binaries for the BIPS. So this was just a very brief guide to get you started with the BIPS on Windows and Linux. You can learn much more from the detailed user manuals, and stay tuned to this channel for further tutorials on how to do other image processes with the free and open source BIPS software. If you like this video, please hit the thumbs up like button and view some of the other videos on my channel. If you'd like to support the project, you can do that by subscribing to this channel and telling others about it. If you'd like to help me continue this work, take a look at my Patreon page, where you'll find additional content and early bird access to future videos. Thanks for watching.